Hello everyone, my name is Bar. I'm product lead here at Upwind, and in this video I will walk you through Upwind MCP server, what it is, why it matters, and how security teams can use it to get answers from Upwind faster, smarter, and more automatically, directly to the tools they are already working with. The core value of MCP is that it allows customers to interact with Upwind data using natural language without manual moving between screens, filters, tables, and dashboards. Instead of searching the information across multiple places, the customer can ask just one question, and the MCP can call the relevant Upwind tools, pull the right data, and connect between the different pieces of context, and return a clear structured answers. This means security team can investigate threats, understand exposure, prioritize vulnerabilities, edit API risk, and check cloud account coverage, and even generate a developer remediation plan, all through one conversational interface. What makes this especially powerful is that the MCP server is not returning generic information or answers that are disconnected from the customer environment. It uses real Upwind data, including runtime context, inventory graph, SBOM, vulnerabilities, cloud account, API security, workflow, and even shift-left data. In the next few minutes, we will walk you through practical examples that show how customers can use Upwind MCP server to get more value from their data, work more efficiency, and turn complex security information into clear actions.
Hi everyone, I'm Moshe, VP of Product and Research here at Upwind, and today with me, Guy from Security Research. We want to show you an active scenario with multiple use cases that can be solved using Upwind MCP server.
So here is the setup. It's Tuesday, and one of our production services, a payment service, has started behaving suspiciously in a way we've never seen before.
Which is the moment every security and platform team is alerted. Normally, that kicks off an hour of jumping between multiple platforms and trying to tailor by hand the entire investigation.
Today, we're going to do the whole thing. Detection, blast radius, root cause, and the fix without leaving this chat. Everything you see your AI setup do, it's doing through Upwind's MCP tools against our live environment.
Let's get into it.
The first question any defender asks, what actually happened? And there it is, at the top of the list. Suspicious API request and a process execution on the payment service. Let's open the full record. Here is Claude reading us the process tree for us. Python 3, that's our Flask app, spawned the shell, which ran a curl to the cloud metadata endpoint. So in one prompt, we already know it's not a false positive. And it all started from runtime, a verified execution, and it's just our beginning. Next thing a defender needs, what else was affected? What can the attacker reach from here? The related detections are aggregated into a single threat story, all on a single asset. We'll query the asset graph to get the full picture. We have an EC2 instance inside a security group, a VPC, with an IAM role attached to it. So the metadata call we saw before isn't theoretical. There is an entity behind it with permissions in the environment. The blast radius isn't just one workload, it's potentially anything that role can access. Let's find out how they got in. We're going to want to have some more information about the endpoint. And what did the attacker exploit? First, we look at what the service exposes. If it's public, which routes require authentication, which handle sensitive data. Let's look at this one. We can narrate instantly to a remote code execution via an unsafe YAML load, a critical CVE. The function in use filter is very useful here. This isn't another CVE in a scan report. It's the one package that is actually being loaded and executed. Also, we can search the entire organization, SBOM, to give us every other workload running the same package and also the fixed version. The remediation and priority process, just in seconds. And here's the entire chain. An unauthenticated, internet-exposed, vulnerable post-endpoint, vulnerable software, malicious payload, RCE, cloud creds. One narrative, 4 different data sources, in a couple of prompts.
A bug is a bug. What turned all of this into a full cloud compromise was the posture around that. Let's ask our MCP. Tell me all of the findings that are surrounding this entire entity in our platform and give me a solution for that. Now let's wait for the AI to respond. The response lines comes like dominoes. first comes the metadata v1 that is being enabled. This is the first sign of an exploitation that's being used by an attacker. Second thing is the wildcard on the IAM role that indicates of a high privileged role that can be remediated and remove the high permissions by the role. The next thing is actually the exposed to the internet security group that exposed the resource and the application outside. And finally, the last misconfiguration is the root access of the workload and the application on the workload itself. So now we can say that in one sentence. An open unauthenticated endpoint on a vulnerable library, on a root process, on a node with weak metadata protection, and a God mode role with a wide open internet exposure. Everything that an attacker wants and everything that fails in around posture. And now, let the agents connect all of the dots and offer us solutions. Triaging is half of the job. The other half is fixing it, and this is where it becomes the real work. The AI setups has the findings and the repo. So now let's try fix some stuff. Let's ask the AI, propose a remediation plan and split it into application fixes and infrastructure fixes, and let's apply those on the environment. Let's start with the application. Let's watch the AI setups edit the actual files. It first patches the CVEs, updates the YAML in the requirements.txt file to the fixed version. Next thing is we're actually killing the unsafe score method in the application itself. The next item is actually add authentication to the vulnerable route in the application itself. And finally, we are going into the plain text secrets and actually starting to rotate that and removing that out of the files and moving that into an API call. Now, let's move into the infrastructure side. Now let's make the platform team work for us, or improving our infrastructure in order to fix those issues. Same thing, now we get results, but for the cloud layer and not the application layer. The first item that we suggested is let's narrow down the internet exposure by the security group. The second item is let's enforce a metadata v2, which is more secure approach to authenticate. The next item is a least privilege method on the IAM role. And finally, we are removing the root permissions out of the service that the application been using. Every one of those gaps is being mapped into a failed issue in our CSPM and in our security posture. The investigation and the fixes are combined together and being involved by the AI into a resolution that you, the users, can actually use now using our MCP server. The context never gets lost between hands and different services and people in the organization. Everything is in one place. Thank you everyone for watching. This was an MCP guide by Upwind provided you on a live scenario that we've been examining in our services and our MDR during our day-to-day activity. Thank you all.